In the following, I'd like to talk about our first attempts at performing MR-guided fractionated hyperthermia in the pancreas of a large animal model using high-intensity focused ultrasound. These are the conflicts of interest. So let's start by answering the question, why do we even want to induce hyperthermia in the pancreas? What is our motivation? The answer is that there is a large unmet clinical need for new pancreatic cancer treatment options. Pancreatic cancer is one of the most devastating cancer types. It has one of the lowest 5-year survival rates with only very limited treatment possibilities. So, our motivation is to provide a new alternative. Our main goal would be to perform HIFU thermal therapy of pancreatic cancer, which means a combination therapy. On one hand, ablation of most part of tumor tissue and, on the other hand, inducing hyperthermia of tumor tissue next to more heat-sensitive structures. And in the following study, we will focus on the hyperthermia part of this thermal therapy. So we would be using HIFU to heat up tissue. But how do we know where and how much we are heating? For getting treatment feedback, we make use of MR thermometry. The HIFU transducer is embedded in an MR bed. The MR itself is used for treatment planning, spatial guidance, and very importantly for temperature mapping. The near real-time temperature information is used in a feedback loop, which controls the HIFU transducer and is able to, for example, adjust the power level or focus position. Moreover, we are also able to put pauses in our treatment, which is essential for applying fractionated hyperthermia. So now to get back to our main goal, applying fractionated hyperthermia in pancreatic tumors. This is why pig studies are currently ongoing to assess safety and feasibility of such a treatment. But what does fractionated hyperthermia mean? It means that we are alternating hyperventilation and apnea phases. HIFU hyperthermia is applied during breath hold, and the treatment is then paused in the hyperventilation phases, keeping an eye on the CO2 level. So far, we have performed 3 safety studies with German landrace pigs. A special bowel preparation was applied, which consisted of a special fluid low-fiber diet with added anti-foaming agents and laxatives. Buscopan was administered pre-treatment to suspend bowel movements. For good acoustic contact, the belly is shaved and bowels are pushed aside by using a gel dome spacer. Moreover, apnea test runs have to be performed to find out how long the apnea periods can be. On a more technical side, we used an MR HIFU system with a recent Sonleaf software build, which includes a 3D first-order drift correction. For thermometry, we use a multi-shot EPI FFE, and additionally, before each treatment, we performed MR warm-up. Now let's have a look at our experiments. Here you see how our very first experiment went. It failed due to strong susceptibility artifacts in the treatment area, which led to an automatic software stop. Nonetheless, we learned a lot and worked on improvements for the next one. We modified the software ourselves by changing the security endpoints and applying stricter thermometry masking. Additionally, to tackle the susceptibility artifacts especially, we added digestive tract filling and administered Buscopan directly before treatment start. And with all those improvements, we started our second experiment, and the results can be seen on this slide. As you can see, we were able to apply fractionated hyperthermia for about 15 minutes. Heating was reproducibly visible in the apnea periods, which were 90 seconds long. But as can also be seen in the temperature graph, the CO2 build-up got too strong with each repetition, which led to increasingly long hyperventilation phases. On another note, susceptibility artifacts were less, but still occurring. We saw increasing drift build-up over time, and we had difficulties to reach the pancreas with our HIFU transducer, which resulted in a lot of repositioning prior to treatment. So for the next experiments, we needed to reduce the distance between transducer and pancreas. For tackling drift build-up, warm-up had to be performed immediately before treatment. To counteract the increasing CO2 build-up, we applied adaptive apnea periods. And for improving image quality, we found out that performing the MR preparation phases during apnea helped a lot, as can be seen in the following slide. This is the same animal, and here on the left we performed the preparation phase during breathing, and then here on the right you can see the image when we perform the preparation phase during a breath hold, and as you can see the image quality improves a lot. So this is one part that really helped. On another part, for good acoustic contact, we added digestive tract filling. So on the left, you can see the first animal where no extra filling was applied, and we have a lot of air bubbles. So it was very difficult to reach the pancreas. And here on the right, we have another animal where a 500 milliliter pineapple juice was administered 5 hours prior to treatment, so that it would reach the big intestines. And as you can see, we had much better acoustic contacts and nearly no bubbles in the acoustic path. So now, taking all of those improvements, we started our third experiment, which was even more successful. We were able to apply 2 times 10 minutes of fractionated hyperthermia in the pancreas with an apnea length of 45 seconds. The improved apnea protocol led to reproducibly short hyperventilation periods and allowed therefore for shorter cooling times in between heating. This led to not having to heat repeatedly from baseline temperature, since a lot of the warmth was still there at the next apnea start. On the flip side, drift build-up was still an issue, which means it should be tackled for the next experiments. This would mean the need for an extensive scanner warm-up or to include a higher-order drift correction in the software. Now I'd like to sum up the challenges we faced during experiments and what solutions and workarounds we found for them. To tackle low image SNR, a big improvement was to perform the MR preparation phase during apnea and to also take more averages. To lower the impact of susceptibility artifacts, we administered Buscopan very shortly before treatment start, applied digestive tract filling with pineapple juice, and added stricter thermometry masking. Against drift build-up, we plan to perform a more extensive scanner warm-up or to add a higher-order drift correction. As for the pancreas not being reachable, the distance has to be reduced. This can be done by repositioning and, for example, tilting, emptying the stomach, or in our case, also using a HIFUS table without a skin cooling layer. If the CO2 build-up was too strong, adjusting the apnea protocol helped. So to conclude, we were able to successfully treat the pancreas of a large animal model with fractionated hyperthermia. We identified various problems and provided solutions which are still also being worked on. More experiments are planned to show feasibility and safety limits. Thank you very much.